designing, manufacturing, installing, and maintaining the high-speed electronic computer, the largest and most complex computers ever built.
Hey, Spot.
Hey, Joey. How's it going?
I'm doing pretty good. How about you?
I'm doing pretty well. We're going to be listening to an interview that we did with Alastair Reid. Can you tell us a little bit about it?
Yeah, so Alastair is a formal verification engineer. Alastair was at ARM for quite a few years, working on some really critical formal methods applications within the hardware world, and has recently transitioned to Google, where he's now trying to apply the same sort of thing, but for software. Alastair's got some really cool ideas about how to bring formal methods and how to bring proof style approaches to a large number of engineers, either in the hardware or the software world. So I'm really excited about doing this interview.
Let's take a listen.
Thanks for joining us, Alastair.
Oh, thank you for having me.
So I'm going to kick you off with our usual question, which is, what is your approach to building better systems?
So at the moment, I'm working on verifying Rust programs and trying to use the tools developed in the kind of formal methods community to do that. And the idea here is I think that kind of we can make programmers kind of more effective using formal verification tools. So help them kind of hit whatever the quality goal is, help them hit it more efficiently is kind of the idea. And if they then choose to kind of like take the time saved and build something better, I'll be happy with that. But just getting people to go, this is worth doing, it makes my job easier, more enjoyable. I'll take that as a win.
So this is a bit of a different perspective than what we have sometimes, which is that formal verification is this really heavyweight thing that you can do on the most important projects. But it sounds like you have an overarching thesis that this is something people could find, the approaches you're building are something that people could find useful from day to day.
Right. And I mean, it's partly that, but it's also that if you say that, I'm going to guarantee your code is correct. Well, one, you're probably lying, but two, you're also setting yourself up with a really hard goal to hit. And you're guaranteeing that it's going to be quite an expensive task. And so you're only going to apply it in a few cases. And so, I'd much rather just get lots of people getting some value out of verification tools and then build on that. And kind of later on, people go, well, if I get a medium number of people getting a bit more value, and then right at the tippy top you've got kind of like the people who are trying to kind of like show very strong properties, but there's not so many of them perhaps.
And until about a year ago, I think you were putting together approaches like this at ARM, or you were working on just how to approach this problem at ARM.
Right, yeah. We were trying to figure out how we could kind of bring formal verification into the company. And there were some sort of like technical ideas, and so I was kind of contributing to that. So we built our formal specification of the ARM architecture, and it's got like all the instructions and all the address translation and all the exception handling, and it's a very complete specification. But then we had to kind of like use that, and okay, so we kind of figure out a way that's kind of very effective at finding the kinds of bugs that normal testing is missing. And it's like, great, we're done. It's like, no, we've got to persuade kind of the teams that they should actually use this. So it's like, you persuade an individual, he's happy, yeah, this is great. But you've got to persuade the tech lead and the project manager that overall their project is going to be better. They're going to kind of like get to alpha a little bit earlier. They're going to kind of have a better time when it comes to integration testing. And finally, they're going to release something to customers that is going to be less buggy and hopefully delivered a bit earlier. And so you've got to do all that. And then you've got to go to the next team and do it with them as well. And eventually you've got to kind of like work your way up to kind of like the kind of senior management and say, so we want you to give us a bunch more money to buy tools. We want to do a bunch more training for people, and we want you to hire some extra people so that we can do this new technique. And then we had to kind of like figure out, well, how on earth are we going to persuade them to spend more money, because they don't like spending more money. So so we had to figure out how to do that. So I did that in hardware, and then switched to Google, and I'm trying to figure out kind of what I can take from that for verifying software.
What's different about the two jobs, verifying hardware versus software, and what maybe surprisingly is similar?
So right at the lowest level, there's a lot of similarities. So they kind of, I tend to use automatic verification tools because I think they give you the most bang for the buck. And so kind of underneath, a SAT solver or model checker is basically the same, kind of like the lowest level libraries you're using. But then on top of that, there's a huge amount of variety in software, different ways of kind of writing it, different languages you write it in, and libraries you're using, all kinds of stuff has a huge amount of variety. And well, at ARM, it was mostly processors. And so we could focus on kind of one thing and one set of challenges that come up in processors. So kind of that, the bit of what you actually do when you're at the keyboard is kind of different. But then kind of like, you get the same thing that what I was talking about is like within the project, it's the same. There's questions like, I've just verified something. I go to commit whatever I verified, and someone has to review it. So can that person who's reviewing it do a decent job of reviewing it? When they look at what I verified, can they go, yep, looks like you've checked everything that we want to check? Or are they going, why didn't you check this? Or maybe they can't even spot that there's something missing there because they're unfamiliar with verification. So there's that kind of team level stuff, and then up kind of the higher levels in the company as well.
If they're, I would imagine that if they're in a position to say, why didn't you check this and why did we verify this? You've already you already bring in a bunch of value because you brought the team kind of halfway to meet you halfway in a way.
Yeah, so we've got to figure out kind of like how to get to that point where they can actually look at something and go, looks like you've done enough, and they can be confident that that's the right answer.
Mm-hmm. How do you this concept of convincing, so to speak, the higher ups about the value of this stuff is very interesting to me. I think sometimes we hear about people feeling burned from formal methods when they were introduced to them decades ago, and it seemed that the promise was much more than what ended up happening. Now, of course, some of those tools were not as deployable, academic prototypes and things like that. So we often kind of meet that now, basically, when the actual state of the tools and approaches is very different. You're doing this at huge organizations that have businesses built around delivering things quickly, right? I'm very curious about how you go about getting people to understand where we are with these tools and approaches.
Yeah, so that's really hard because there's all kinds of messages kind of floating around any company about what formal verification means. And so I suspect that what I'm going to end up doing is trying to avoid using the words formal verification and just kind of like, this is a better way of testing, which, if you want to get value out of the formal verification tools, then just treating it as a better way of testing things, and maybe not even worrying about, soundness. It's like, it's okay to miss some bugs, but we'll catch some really important ones. That might be a successful message. And then you can kind of like go from there. But at the moment, they're so used to things being oversold, and there's all kinds of things that they know will not work, and they'll be promised the moon and they won't get it. that you have to be super careful about what you say and what other people are saying about your work as well. You have to be kind of careful about that. So.
It's interesting before we started recording, I asked you how your day was, and you told me excitedly that you spent it working on proofs and just kind of technical work. And then when you talk about this, having these conversations and debates, I feel like you find as much joy in getting people on the same page about this stuff as in some of the technical stuff. Is that how correct is that statement?
Do I get joy from it? I'm not sure about joy. I it's one of those things like writing a paper where it's like I'm really glad when I've finished doing it, but when I'm actually doing it, it's like it's just the most miserable thing in the world. So,
but the end result.
Yeah. So if I, when I can persuade someone kind of like correct someone's viewpoints and things, yay. But,
right.
If I could avoid having to do that and just focus on the technical stuff because someone else was, doing that, I might be happy with that too.
You're doing it out of necessity.
Yeah.
Cool.
And I think part of the idea, hopefully, is that it's you have to get the momentum started. But like, obviously, no successful approach has been one person sort of going out and calling up every developer and saying, "Hey, this is the way to think about this. This is." So part of what it sounds like you're going after is trying to figure out the right approach that can see the kind of growth that any successful tool sees, which is, not calling up people one by one and saying, you should use this because, but people saying, I need this because it's obviously the way to do things.
Right. So there's actually two of us at Google working on this, myself and Shakid Fleur, who's also in the London office with me. Well, in the London office, meaning somewhere not actually in London. So Shaq and Fleur and I are working on this. But yeah, so we've got a bunch of kind of technical issues we have to work through, but we've just started trying to put together some case studies to show mostly kind of what kind of specifications might you write, what are the properties you want to try to check. And the approach we're taking is that we write the properties in a way that they can also be used with our property-based testing library, so to do some kind of fuzz testing. We're trying to write this, we've only just started, so we haven't got very far on it, but we're trying to write up a series of case studies where we go, you know what, in this case, this is the way to specify this, and in this case, testing catches pretty much all the bugs, is not a problem. Using a formal tool would not add much. In this case, there's a lot of tricky corner cases, and we think you would get something, and so on, and trying to kind of explore what the advantages are, with the idea that we can use that to teach people how to use our tools. And when people say, "Hey, what are your tools good for?" we'll actually be able to give them an answer with some confidence.
So it sounds like you're trying to automatically even identify places where people might get mileage from using better formal approaches. And the idea would be to avoid this scenario where somebody takes a bunch of time writing a specification, for example, and then applies it to a program. And it turns out everything was fine from the get-go. And then they realize maybe that wasn't worth their time.
A bit of that. I mean, building a specification is just incredibly hard work. I mean, that's the main thing I did at ARM for the last 8 years, was building a specification of the architecture. And, for something like that, for a processor where there's lots of potential different users, it's worth doing. But most of the time, you put a lot of effort into creating a specification, and you're not actually going to get much value from it. Or you have a really simple specification, but you also have quite a simple implementation. And it turns out that your specification and your implementation are almost identical, in which case, sure, it's easy enough to do, but are you actually likely to find many bugs if you're just checking that the code is equivalent to some almost identical code? So yeah, specifications are just incredibly hard. So we're also kind of wondering, kind of like, what can we do to avoid having to write like a full functional specification? And there's things that a lot of the automatic verification tools have been used for C is you just go looking for memory allocation errors and buffer overflows and other things like that, which they're not what you want the program to. You don't check what the program is doing, check it's doing the right thing. You check it's not doing the wrong thing. So you know for sure it shouldn't be dereferencing null pointers. So you check for that. And the nice thing is that's the same specification for all programs. So the specification effort is like 0, or it's like, what command line flags shall I use this time? It's really easy. So yeah, we're interested in kind of like how we can keep the specification effort really low as well.
And I think another thing I took away, I read the paper that you published recently, and I think we have similar approaches in a lot of our work, is the idea that if you can get someone using that tool and start to understand what's possible, then their own curiosity might drive them. If you have the quick static analysis that gives you some of the bugs, but not all, but they sort of have this inkling feeling that maybe it missed something over in this area. If only the tool could know a little more, then all of a sudden the developer's asking the questions, and that learning curve gets so much easier at that point when they start asking, how do I show more? How do I take the next step? All of a sudden somebody's not telling them to write a specification, rather they're going out and doing it because they want to make things better.
Yeah. And the thing is, what's the gateway drug that's going to get them started in this and kind of want to do more?
And the gateway, yeah. And we've seen things like, I think Facebook Infer is obviously springs to mind when you mention quick static analyses that turn things up. And I think Rust as a whole could be viewed in this way, right? We're seeing lots of people switching to Rust from C and C++, and why are people doing that?
Right. And the nice thing is they're doing it because they're tired of having these stupid bugs in their code. They've actually, and in particular, they want more reliable code. Right. You look at the kind of various projects that companies are doing involving Rust, and it's usually kind of bugs in this piece of code would be really bad. Therefore, we can justify the effort of, having to learn a new language before we can get started, and not having such good tool support because it's early days, and all the other costs of using a funny new language are justified because they want the higher quality result. And that's great, because if we can offer them a little bit higher quality, then they're open to it. Whereas if I take some random C or C++ programmer, they may care about kind of improving quality, but they may care about performance much more, and that may be their focus. With Rust programmers, you're pretty sure that the kind of quality of the results is important to them.
By the way, the paper, I think the paper Joy was referring to, just for people who might not be aware, it's called Towards Making Formal Methods Normal, Meeting Developers Where They Are. And you've recently published it with a bunch of other co-authors. We'll share the paper. What we found it very interesting. I'm sure Joy has a bunch of questions about it. I'm curious, from your point of view, what the main takeaway from this work was.
So I guess it's a mixture of things, because the paper's about maybe like 3 or 4 things. So one is, and maybe the main idea is this kind of meeting the developers where they are. So what that means is you say, well, I could aim for the early adopters who will pick up a new tool and try it just because, they want to see, is this any use to me? It looks fun, whatever. And they're willing to put up with quite a bit of pain to do that. But that's not most programmers. Most programmers are, well, it's maybe a fair number of programmers, to be honest, but there's also ones who kind of like, they're already kind of like busy, they don't have a lot of spare time, and they've got a job to do and a deadline to do it by. And so what you want to do there is not say, hey, I've got this exciting new tool that requires a bunch of training and is going to crash every now and then and won't accept all your code, and a list of other things which the early adopters will put up with. You instead want to be able to say, here's this tool. It's actually not so very different from what you normally do, right? So the meeting developers where they are is saying, what do they normally do? Well, they're all running tests. They're all doing code review. They're all, a fair number of them are fuzzing. There's things like that. So it's like, are there any of those that we can kind of like benefit from and make formal verification enough like that the training is fairly minimal, and it's just like, here's a different tool to use. And so that's kind of what we're trying to kind of like hook into with this kind of property-based testing approach we're taking. It's like, okay, this is a way of doing fuzzing. Oh, programmer. Yeah, fuzzing, I'm familiar with that. I know something about it. But this way of fuzzing is going to find the obscure corner cases that random values won't catch. Okay, there's a bit of extra value. And hopefully, if that actually comes out when they actually try it, then they go, okay, this is doing something that, I wasn't getting before.
This difference between developers that are actually working on something, well, most developers are working on something, but people who have time to just try something for the sake of trying things versus, use it in an actual project that they're delivering. For some of these tools that require a lot of effort and investment of time, I could see how that's a hard sell. Yet, in our mind, sometimes, at least in mine, there's this view of like, if somebody will take the time to try this thing because the value might be there. But the truth is that people have been doing things this way for a while, and it's not like it, the whole world isn't, software is crashing and burning, but not as much as you would expect. I see what you mean. It takes a lot of kind of effort for things to be effortless in a way that people will use them.
Well, and even early adopters have pain thresholds, right? Like the early adopters aren't these people that you can just torture with the worst tools because they're so excited, right? Everybody's got a point where they're going to put something down and say, this is not worth my time. And a lot of formal methods approaches and a lot of the proof tools out there today, I don't think have even gotten under the threshold for all but the earliest of adopters, who I think we would call PhD students in most corners, right? It's somebody with a full-time job that is not doing early adoption work is probably going to shy away from a decent fraction of the tools out there. So bringing that pain threshold down is really important, but it's also a real interdisciplinary problem, I'd say. Like I think it's not something that just people like you and I can solve on our own, because we aren't great at user experience.
Right, I think this is something that Gene Yang was talking about in the in that kind of first podcast you did about just trying to make it look at what developers are doing, kind of what they need to understand to use something, how to make that kind of fit into their workflow, and that was kind of that was the kind of the core of the paper. Was I'd actually never worked with user experience researchers before. So it was kind of interesting just kind of getting together with them and trying to kind of like figure out kind of what they knew that they could bring to this, and persuade them that, the kind of problems I had were the kinds of thing that they might be interested in thinking about. And it turned out that so Google and you mentioned Facebook earlier, they've both got this thing of doing kind of in the code review process is when they show static analysis results, because programmers are still kind of like willing to change kind of the code at that point. If you wait until the weekend before you run your verification again, and you then show them a bug involving code they wrote last week, it's like, no, I'm done. I can add that to my priority list. Where shall I add it? Up here? No, a bit further down here is where I think this one deserves to go. But get it to them as the code is being reviewed, and they and the reviewers will kind of start going, no, actually, we should fix this now.
Yeah, there's no question that it's the sooner the better. The best possible is the red squiggly underline as they're typing it, and from there the priority just continues to decline. And yeah, the Facebook infer insight is that it hits the threshold of where it's too far down on that priority list. It hits that very quickly. That
Yeah.
fall off is quicker, I think, than I would have expected until I had more experience with development, and of course the paper that just says it really plainly that they observed that. One of my favorite parts of the paper that you wrote is that it does actually have this really diverse author list, including not just formal methods researchers, but I believe product managers as well as full-on UX researchers. And the paper actually, I can tell which bits were not written by the formal methods people, because all of a sudden I hit this part where I couldn't understand anything and I had a bunch more research to do to start learning about UX stuff. And it was really cool to see that in your paper.
Yes, as we were writing the paper, they'd start referring to bits of work, and I go, "Can you give me a citation for that?" And they'd add a citation, and it's like, "Okay, now I'll go and read the paper or whatever, so that I know what they just said." Yeah, that was one of the really fun things working on it. Was just kind of like being exposed to that, and then going, "Oh, right, there's a bunch of stuff I can read here." And people have solved problems which kind of overlap with what we've done. So let's just read a bunch of it. Yeah.
Good job picking that one up, because I didn't actually ask you a question. I just said something nice and let you talk. So you still had something to say, but I realized after the fact that I had just sort of, just complimented you and then expected you to say something. So, but yeah, well, so, and I guess I think a lot of people's familiarity with you might be from Googling papers and landing on your website. You undertook this really cool project to catalog all the papers you read for a year, which, by the way, was sort of an insane number of papers, even by, I think, many academic standards. Can you tell us a little about that project?
Yeah, so it was, I guess it came out of, as I was finishing off my PhD, and which was a couple of years ago, and kind of preparing for the defense and just thinking about what I'm doing, I thought, okay, I'll reread all the papers that I cite. And then I'm, of course, cursing how many I cited and so on. And I read them in chronological order from oldest first. And it was really fun seeing the way that field had developed. So it's like, okay, I quite enjoy just the rereading of the papers. And I also knew that, so I'm living in Cambridge, England, which is about a 1 hour train ride from London, where the office is. So I was just changing to work at Google. And so it's like, what shall I do on that 1 hour each way? And, obviously I could read books and listen to podcasts, but I'm probably going to read papers. So I thought it would be fun just to kind of try to write summaries of them. And yeah, and a large number of papers because, 5 days a week, I have quite a lot of opportunity to read papers. So.
Yeah, that explains the number, which is 122 papers that you read and summarized for people to kind of have access to the summaries from your point of view on your website.
Yeah, and it became harder to do it once I moved to working from home because the commute was that bit shorter. And so instead I'd kind of read a paper, I'll summarize it tonight, and then I never would. So
just like the developers with a bug at the end of the stack.
Yeah,
I'll summarize it tonight.
I've been feeling that pain too. My Nintendo hours have dropped way off since I stopped riding the bus to work. So, you and I are in the same boat here for sure. It's barely time. Can find time now. So going back to your paper now, there was the whole thing slightly revolves around this prototype that you've built at Google. And I think a prototype because it came together remarkably quickly. But it still sort of seems like it's maybe given you some useful early results. Can you tell us a little bit about what you built?
Right, so we wanted to build on this idea of kind of making things feel like testing or fuzzing. And one of the libraries that people use for testing Rust programs is something called prop test, and it's a property-based testing library. So anyone who's familiar with quick check for Haskell or quick check for Coq or hypothesis for Python will have used one of these. And it's basically it's a fuzzer with a good user interface for saying, here's the kind of random values I want to generate, and here's how to generate structured random values. Then you have some code that it runs, and that code might contain some assertions that fail, some arithmetic that overflows, some assertions that fail, whatever it is that's going on in your code. And then it acts like a fuzzer. It generates random values until it finds something which fails. And then when it finds something, it tries to shrink the value down and produce a simpler value. So it's quite a nice library. It's quite easy to use. If you try using it, it's kind of quite effective for things where random values have a decent chance of finding problems. So it's pretty good. And so what we wanted to do is say, okay, can we use that same interface for verification? So instead of creating random values, we create kind of symbolic values, and then the verifier kind of tracks how those are used through the program. It hits an assertion or whatever, and it tries to find some values, some concrete values that will make it fail. And so that's sort of the basic idea. So we just kind of took the prop test API and re-implemented it on top of our kind of verification API. And so that's working pretty well. I'm actually spending a lot of time at the moment just working my way through corners of Rust, which it turns out don't work because they make our verification tool unhappy. So let me see. This morning I was dealing with one to do with memory allocation, and I managed to get that one fixed. And then I found that some Rust code was checking, do you have this vector instruction available? Because I want to use it to accelerate this piece of code. And so tomorrow I'll try to figure out how to solve that one. So there's just lots of things for how to get tools which were originally designed for verifying C code, trying to adapt them to verify Rust code. I think industry often finds kind of new problems that nobody had really understood was a problem worth solving. And so kind of hopefully you get academics to do that. But yeah, you're right. We build on top of all that academic work. So at the moment, I'm mostly using the CLE symbolic execution tool, which is from kind of Imperial College London. We're just in the process of merging in some support for Seahorn, which is from University of Waterloo. And we've also got some support for Cruxmere, which comes from Galwa, of course. So yeah, we're building on all those things. We're actually, I don't think I can build a better verifier than those people can. In fact, I'm quite certain I can't. So I'm going, okay, well, what can I do that does add value? And then kind of make that available so that kind of the community as a whole can figure out how they want to verify Rust code, how they need to change their tools to let them do that, and yeah, just generally get better support for Rust verification out there.
And so just to reiterate what you've done with this prototype, you've basically taken this thing that people are already using in Rust because they find it useful, this prop test, and you've found a way to hook up, it sounds like, multiple industrial and academic tools in such a way that they can all, a user can smoothly transition from the prop test that they're already using into using these tools and probably get better results than they were getting in the first place. Is that an accurate summary of what you've done?
Right, yeah. So I want them to be able to kind of very easily swap back and forth kind of between different tools, because, sometimes fuzzing is going to be, all they need, or it might even be better in some cases. Sometimes they need kind of the kind of analysis that a formal tool can do. But again, there's kind of differences, depending on the scale of what they're doing and so on. They might want to use one tool or another. So if there can be just one interface that you use for all your formal verification and ideally a fair chunk of your testing, I think you kind of got the best of both worlds.
And even amongst the more formal tools, I don't understand exactly how you're using them all, but there's even a range there, right? I think CLI is sort of doing this feedback loop, as you mentioned, between trying to do concrete exploration, so trying to generate basically smarter test cases from your fuzzer, whereas something like CruxSmear is really about getting more thorough guarantees across your test. And so even amongst these formal tools, there's actually a spectrum of use and application, right?
Right. You can get CLI to a bit reluctantly kind of check everything, and but it's more comfortable looking for for bugs or generating test cases for you. Whereas, something like CruxSmear is going to be kind of trying to check a property as a whole. And they're gonna scale different ways. CLI tends to have a problem where it has this kind of time explosion where it finds too many paths to check, and so you get this kind of explosion from the number of paths. A tool like CruxSmear, if I haven't actually used it enough to be sure that it does suffer from this, but that kind of tool tends to suffer from using far too much memory and making kind of SMT solvers very unhappy. So you're going to switch back and forth. It might even be within the same program. You're verifying one bit one way, another bit the other way. So yeah.
As you were talking, I actually realized that as we were making jokes about people with incredibly high pain tolerances, that you are definitely an early adopter with an incredibly high pain tolerance to be taking not one but three verification tools, 2 out of academia, and mashing them together into a prototype. You've unquestionably qualified for the pain tolerance medal at this point.
Well, thank you. But I actually managed to trick my colleague Shakid Fleur into doing 2 of them. So,
all right. So you get the silver medal in this case. We won't give you the gold.
Shakid gets the gold. Yeah.
Not bad, anyways.
Alastair, it was a privilege to talk to you. Thank you for spending this time with us.
Oh, thank you. This is great. Thank you.
Yeah. This was another episode of Building Better Systems. See you all next time.